Good afternoon, everybody. Wake up from your food comas. My name is Camille Fouvnier. I am the CTO at a company called Runway, and I am here to talk to you about how we have scaled our reverse logistics. Imagine for a moment, I know this is going to be a feat of empathy for many of you, but imagine for a moment that you are Cinderella getting ready for the ball and your hair is beautiful, your makeup is perfect, your jewelry is amazing, your shoes are very on point, and your dress does not arrive. You have no dress, you've got a carriage waiting, no dress to wear, alas. This is what Runway's logistics must contend with every single day. We are constantly at risk of not providing some would-be Cinderella with her amazing dress if we do not fulfill our promises. Since its launch in 2009, we have grown from around 400 units of inventory to about over 65,000 today. We started on a rack at a dry cleaner's, and now we are bursting at the seams of a 40,000 square foot warehouse. And we have learned quite a bit in this process. You can go a long way on scrappy logistics solutions like Google Docs and other manual efforts, but in the long run, it takes a lot of intelligence and a lot of complicated software to run a really good logistics operation. So I'm going to tell you a little bit about that. To start with, we will begin in the beginning with a brief intro to Runway, because many people at this conference have asked me, what is that again? You're not exactly our target demographic. Runway, we rent designer dresses and accessories for short-term rentals, 4 or 8 day rental periods. You pick a size, you pick a backup size, we ship it to you, you get it, you wear it, you look beautiful, take a bunch of pictures, put them all up on Facebook, and we send you a return mailer that you put your dress in, put it in the UPS box, ship it back, all right? Simple concept. I've had many people come up to me and say like, oh yeah, I had that idea, that was such an obvious idea. It is, in some ways an obvious idea, but when I say reverse logistics, the title of this talk, right, scaling reverse logistics, one thing that is implied here is that unlike many standard e-commerce companies where they're dealing with things leaving their warehouse, pretty much every single thing we ship out has to come back to us, and we have to manage that process. So we launched in 2009, as I said earlier, in a dry cleaning facility. So, something like this, right, where we had a couple of racks that we rented because the founders knew that dry cleaning was going to be a big part of this operation. Well, they were non-technical founders. So they thought through a lot of things about launching this company, right? Like, of course, we do need a website, of course. We need dry cleaning. We need to think about how we're going to ship things. But one thing that they did not think about was, oh yeah, we got to manage our inventory. And so one of the early developers, hammered out some really, really quick hacky code in that first week of launch to create the very first warehouse management system for Runway. Now, of course, any system built in the week of launch probably has a few bugs, such as, remember how I said we send out 2 sizes? Well, the original version forgot to track the second size. So being the scrappy people that they are and having maybe at most 200 orders, our founders and the original team got on the phone and called all the customers, pretending to be customer service and just trying to get their feedback on the product, since this is a new product. And in the process, asked them, oh, which size fit? And how about the other size? And what was wrong with that size? So they could actually track and make sure that they got all the sizes back to them. So, this is a perfect story of the scrappiness as a virtue core value of Runway. We quickly grew out of that dry cleaner. So once we went to about 2,000 units of inventory, the dry cleaner was like, you cannot keep your stuff here anymore. So we moved to space in our actual offices now. So first on the same floor as the rest of the workforce, and then they actually rented another floor in the building that we're in now. And this was the period of growth from about 400 to about 8,000 units. Now, this is still a fairly small amount of inventory, certainly compared to what we're managing today. And so there were still a lot of little scrappy, hacky things that were done. For example, if you go to our website, you will notice that all of the products have catchy names, such as the Fifth Avenue Showstopper dress. For a very long time, the warehouse was expected to know the names of all the dresses. In fact, they made flashcards for new people. And they would actually flashcard, say like, which dress is this, which dress is this? Because we didn't refer to the dresses by their SKU or their style ID. We said, oh, yeah, I need a Fifth Avenue showstopper at size 10. Okay. How about tracking that inventory? Did we have barcodes or some way of knowing what was what? Not really. Not in the early days. In fact, getting barcodes to stick on dress labels was one of the harder problems in the early days of Rent the Runway. So we didn't have barcodes on our inventory for quite a while. We just sort of knew, oh, we have 3 of this size and 4 of that size. And, you know, roughly we're tracking just the basic quantities. So you can imagine that this causes a lot of problems. In fact, one of the problems it causes is you've got inventory, it's going out to customers, it's coming back, it's going out to the dry cleaner. We didn't have a dry cleaner in our warehouse at that time. Sometimes it gets misplaced. And so we have a state that still actually exists in our system today called limbo, which means we don't know where it is. That item went into limbo, and now we need to figure something out. We didn't really think about shipping very well. I think the founders, of course, knew that shipping was going to be an important thing in this business, but we didn't really ever quite know when things needed to be shipped out. So you can always ship UPS next day air, although that's really expensive. And that ended up being a large part of the shipments in the early days because we didn't really know, can we ship this out now or do we have to wait because it's going to be needed for something else? And one of the actual key intentional strategic decisions early in the business was to have returns done via USPS. So there are some benefits to that, right? 2-day priority mail, whatever, USPS is relatively cheap. And there's USPS boxes everywhere. Everybody has one at their house. That's good, but on the downside, USPS doesn't track anything. So we had no idea if the customers had actually returned something until it came back to our warehouse. USPS is also not the most reliable carrier in the world, and we had no idea, is it going to be late, is it not, when's it going to come back to the warehouse? This, of course, causes a whole bunch of problems when you're trying to maximize the utilization of your inventory and, you know, get things, you know, to and from very quickly and really know what's going to happen in the future when you're actually going to get those things back. Picking orders. How do you actually get the stuff that you're going to pick out to ship? Well, in the early days, we didn't have any kind of allocation system or any kind of intelligence. It was just like, well, here's all the orders for the day, and here's the products in those orders, so try to find the stuff, and if it's there, great, ship it out. And if it's not, well, it might be in limbo, and then you have to call the customer and do some stuff, or, you know, oh, maybe it's at the dry cleaner, let's run down to the dry cleaner and yell at them for get it back faster. There was really just sort of no rhyme or reason or priority to the process of getting stuff shipped out. Okay? And finally, of course, there is the question of how far can you go with Google Docs? The answer is very far. This is the Bible. Okay, no, this is the actual Bible. But we had a document called the Bible. What was in the Bible, you may ask? Pretty much every important thing about our customer service interaction was in the Bible. So, you know, something can't be shipped. For example, the warehouse is having a problem with some item, and they say, oh, you know what, this is not going to be able to ship. How does the customer service team know to call up that customer and get them something else? Tell them, oh, anything else that's available today, we'll get that out to you, and then tell the warehouse what to fill? Answer is put it in the Bible. Here are the heading columns of the Bible. And 31 different potential columns that you would have to fill in this shared Google Doc that of an increasingly growing customer service and operations team. You can imagine that this works when you've got like 5 really smart people working customer service, as we did in the early days, and 5 really smart people working operations, and when you've got like 50 and 150, not so much, right? It works until it doesn't, just like all of this other stuff, right? Communication, great, but there's no real error tracking. We would have problems like, whoops, somebody selected a whole bunch of rows, meaning to copy paste them, and instead just deleted all of this status and all of this information, and we have no way of knowing what that stuff was. We also actually frequently, this was, you know, back in 2010, 2009, 2010, 2011, would hit the limits of Google Docs. the row limit or the concurrent users limit. It causes a lot of problems. It really did not scale as well as we needed to. And so, all of these things that we did in those early days, I actually think were the right things to do, right? We had no idea whether this business was going to be successful or not, right? Early stage startup, you don't want to invest a ton of time and energy into software that you don't need, because the business is not going to succeed. But it's sort of like, building a naive algorithm, right? If it's O of n squared and n is really small, it doesn't matter. But once n gets bigger and bigger and bigger and everything gets slower and slower and slower, you start to see a lot of problems. And we started seeing those problems. And so sort of middle of 2011, we knew we really needed to add a lot of technology. Before I go into what we actually built, I want to give a just quick review of what warehouse management systems tend to do, because probably most of you are not experts in warehouse management systems. I certainly wasn't, and still am really not, but until I came to run the Runway. So very quickly, if you have a simple warehouse management system, what are you trying to do? You're trying to pick from the shelf or the rack or whatever, pack it in a box and ship it. You're trying to minimize your human labor costs, right? You want to have as few people as possible able to do these operations in the size of the warehouse you have. That's the focus. You have very simple allocation of items to orders, right? Most e-commerce websites are not selling things that they don't have on hand. It's very simple, right? You keep your inventory in sync with your warehouse, so you're pretty sure that if you get an order in, you can pick it right then, or pick it in a batch, what have you, and get it out to that customer the same day. If you were starting a new e-commerce business today, and you said to me, Camille, what should I do about warehousing? I would say, outsource the whole thing, because until your business gets to a certain scale, it's just not worth doing it yourself. The other thing that most warehouses don't have to deal with very much, or to the level that we have to deal with it, is limited inbound processing, which means stuff coming into the warehouse. You've got returns, you've got new inventory, yada, yada, but it's probably not the biggest process that your warehouse has, and it certainly isn't as time sensitive as it is for us. So what do I mean when I say that, right? What are Rent the Runway's unique problems in creating a logistics system? We have time-sensitive, full reverse logistics. All right, what does that mean? What does that mean? Okay, everything that goes out comes back. And in fact, we are dominated by Wednesday peaks because, of course, we are renting special occasion dresses for the most part, right? What does that mean? Most of your special occasions are on a Friday night or a Saturday night. So most of the stuff goes out of the warehouse on Wednesday. And if you ship it back if the customer ships it back on Monday, it takes 2 days to get back to us. It comes back to us on Wednesday, which means that in peak days, we might do over 60% of our inventory coming in and going out of our warehouse in the same day. Now remember, we are talking about dresses, which means that we have to do dry cleaning. We have one of the largest dry cleaners in the United States in our warehouse, and we will probably have the largest one very soon as we move out of our current warehouse facilities. This is, by the way, our Chief Analytics Officer, Vijay, who is the data brain behind a lot of these systems, standing here with these bins and bins and bins of dresses waiting to be dry cleaned. You can imagine that dry cleaning is not a super fast process, right? It's not just a matter of 5 minutes and you're done. No, it is actually one of the major bottlenecking processes of our operation, and about 80% of the stuff that comes back into the warehouse has to be dry cleaned. If you even tried it on, we're gonna dry clean it. We don't want to be sending something to someone else that smells like their perfume or their deodorant or worse. In fact, one of the things that you do when you receive items into the warehouse is you do something called the sniff test, where yes, you smell the dress to see if it has been worn at all. Of course, another thing we have to do in our warehouse is repair things. We have a large team of seamstresses actually hemming, sewing on missing sequins, doing minor repairs to our inventory. So sometimes, we insure our customers. We say, look, if you damage the dress, that's fine. We will, you're covered. But that means we have to repair it. We not only have to clean it, we have to repair it. So we have a couple of really human labor intensive processes that have to happen every day for us to be able to fulfill the orders that we need to ship out. So what are some of the initial innovations that we had to put into place to get this thing actually scaling and working well. First thing was smarter reservations. So what you're seeing here is kind of like a cool data viz that one of our data scientists did of reservations and how they flow to customers and how they flow through the warehouse. So each of those gray things represents a dress in a certain style. That's the barcode. And the green bars are actual time with the customer, so the actual reservation. The yellow bars around those green bars are the actual shipping time. And those little black lines you see, that's moving through the stations of the warehouse. When we originally launched the website, there was a very naive algorithm for taking reservations that, sort of worked, but sort of really didn't. It didn't really take into account shipping in the right way. It didn't think about the fact that people are going to return things late sometimes, and that inventory eventually is not going to be usable. So we created a new reservation system. This is one of the first projects that I did at the company that is actually not only accurately models reservations very efficiently to get the maximum number of reservations on a unit at any given time, but also accurately models transit time, has a predictive model of lateness so that we actually say, like, you know what, if we have a certain number of reservations already taken, we predict that a certain percent are going to be 1 day late, a certain smaller percent are going to be 2 days late. It accurately models things like decay over time so that if you're booking really far in advance, we are sure that we're still going to have this item available to you. In short, we tried to do something, and I think we successfully created something that is smart enough to get the maximum available inventory to you at any given time, but also smart enough to not disappoint you, right? Because we don't want to disappoint our customers. All right, another basic thing we had to do, that was not very basic, but this is actually tracking the inventory. Remember that limbo state, right? We got to track this stuff. We got to get those barcodes to actually stick. Again, that was a feat. So we got the barcodes to stick. We finally have barcodes on the inventory. Now, this sounds fairly straightforward, but remember, like, you've got 10 units of a dress, and those barcodes sometimes fall off. So you have to think about, how do I re-barcode things when the barcodes go missing? How do I think about the ergonomics of tracking these things throughout the warehouse? Remember, you've got humans doing all this stuff, and they're being watched on how fast they do whatever processes that they are going to have to do. So if you're making people scan things at every station, as we do, as we need to be able to tell what our inventory is doing, what happens is that your tracking system needs to be really fast and responsive, and when it's slow, you get a lot of angry emails from your operations team saying, hey, WMS is slow, what gives? Once we finally had tracking, where we knew where our inventory was, and limbo became, for the most part, a thing of the past, and once we finally had accurate reservations, we could start being a little bit smarter about allocation. So now, instead of saying, here's all the orders today, good luck, we could say, oh, here's all the orders today, and these are the ones that we're pretty sure are on the rack, go pick them now. These are the ones that are incomplete, that you're going to be waiting for something to come through cleaning or come through repairs or come through something before you can ship it. Now, this was a great, iteration in our allocation process, in our warehouse processes, but it was still pretty slow. It was going against the database. This process took like a couple of hours to run, so we could really only run it once or twice a day. But hey, it was way better than just running around like crazy people trying to pick things and not knowing what's going on. The final sort of high-level decision that we made around this time was to start moving towards an event-driven system. So start, instead of just communicating via whatever HTTP requests or storing everything in the database and everybody reading database data around, we actually started messaging status about orders and inventory around, so that anyone that's interested in any of these systems that we were building out that had the need to know what was where or what the status of the reservations were could know that in real time and do work when that notification came in. This is really useful and important for us because this is what let us actually scale logistics for the future. So the very first thing that we did, once we got all this basic work done, we had this basic allocation system. Now, one thing you should know about our business is this. It is less so today, but certainly in the early years, we were very seasonal, which meant that pretty much people rented for prom a lot, and man, you do not want to screw up someone's prom dress, okay? And people rented for like black tie holiday parties and New Year's Eve, okay? So we had like a couple of really peak seasons. And every year the business grew, and every year those peak seasons got worse. And what happened, it didn't happen this year, but certainly happened in 2013, was we realized about 2, maybe 3 months out, looking at predicted demand, ooh, we are not going to be able to handle the workload if we don't change something, if we don't fix these systems. So imagine that you are an engineer and you have just been told, hey, business can't run if you don't figure something out here. It's got to be faster. You got to do something new. So the team did some pretty freaking amazing work in a very short period of time to create these more scalable systems. The first thing they had to do was scale allocation. So this is a real picture of our warehouse. I actually took this earlier this week. This is the receiving part. So these are all a whole bunch of UPS packages coming back from our customers. What's in them? Well, dresses, probably, hopefully. But who knows what dresses, right? We don't need to open every single one of those packages. We only need to open some of them. But we want to know exactly what's in all of them and what orders we have today so that we know exactly which ones to open and which ones to process. So enter a system called Alligator. You are now going to hear me say some buzzwords. Ready? Our strategy-driven, real-time, reactive allocation system. All right. Truth be told, Alligator is the sort of brain of our warehouse. It really is strategy-driven. It really is reactive. It has an event loop. It is stateful. And it is all these things because it has to be really smart and really fast. What does it do? Simply, in the simplest case, it takes all inventory and possible reservations to be filled today and allocates inventory to reservations via a cost function. What's a cost function? Well, this is an example of a cost function. We're taking a whole bunch of information about reservations, a whole bunch of information about the status of inventory, information about the status of the orders that we have, and allocating inventory to orders based on those functions. And occasionally, there's going to be things that don't have inventory associated with them, right? Interesting things about this strategy basis is that all of these parameters are stored not in the code itself, but actually read out of the database, which is nice because it means that our analytics team can go off and make models and do thinking and change some stuff, and we don't have to actually change the code to create better algorithms for this strategy, this cost function. So what happens? How does this thing work? Well, it listens to events all the time. So it listens to scans around the warehouse as inventory is coming in. It listens to events about orders being taken. By the way, Rent the Runway will take orders up to 3 p.m. the day before, or even the day of if you're in New York, for orders to be shipped out. That means we've got orders coming into our system all the way up until kind of the last possible instant that things can be sent out, which is really quite a challenge, actually. And so we have to be really fast. We have to know about all of this stuff immediately and send people into action the minute that we find out something has changed. This is a very, the nice thing about this system is that it is very fast. It allocates in a matter of milliseconds. And because it knows everything about the state of inventory and the state of reservations, it can really drive a lot of this intelligence behind all the processes in the warehouse. And it lets us scale physical operations. So what does this mean? All right, remember I said we have all these packages, we have no idea what's in them. So 60% of our inventory is going to come back in the day that it needs to be sent out. Dry cleaning takes a really long time and is a bottleneck. Repairs is a bottleneck, but most things don't have to be repaired. We do not want to do any work we do not have to do. If we do work we don't have to do, we will not be able to get everything done, period. We do not have excess capacity on peak days. So what does that mean? Well, among other things, it means that we need to know exactly what needs to be processed right when we scan it. We don't even open packages that have things in them that we don't need. We record that we got them. A little bubble pops up that says, is this important or not? If it is not important, put it away, deal with it later. Deal with it once everything that's done today is done. There's actually even more to this because, of course, if we know that it's going to be needed tomorrow and we have a little bit of extra time, we'd rather just go ahead and get it done today so that we don't have to deal with it tomorrow. But this is, driven by our allocation system because it knows everything that's going to be needed. In fact, it sometimes knows everything that's going to be needed tomorrow, and it can very quickly say, what is the priority on this unit? So now we actually have brains, but we need to be able to do a thing that we call cross-docking, which is when something comes in and goes out the same day. So remember what I said, which is that our business really needs to be able to do this. On peak days, we do 60% of our inventory this way. Before this system, the Bay Watch, the allocation Bay system was created, we could only do about 400 units cross-docking a day. The complexity of the way that you had to physically manage creating incomplete orders and finding stuff that was being completed and joining it with the incomplete orders was really just way too hard for people to do by themselves. It wasn't going to work. So we needed to be able to do thousands and thousands of units coming in and going out the same day, and we created a system called Baywatch to do that. Now, what does Baywatch do? It's fairly simple. It is a series of physical bays, allocation bays, which will really just actually look like this, okay? There's these big sort of holes that you can hang orders in, and there's a bay, and what happens is when you start up the day, the allocation system runs, and it says all of the orders that can be fully picked. And the bay system goes in and says, okay, give me all of the things that I can go out and get. And I'm going to go out and get all of them in a batch. I'm not just going to get order by order by order. I'm just going to get a whole bunch of them, bring them over here, scan them in, put them in the slot that corresponds to the order. And once that's done, I'm going to indicate that it's ready for shipping. And the shipping team can come and grab these as they're ready and put them in a box and ship them out. This was really important to us for scaling, because if you can imagine you have a bunch of stuff that's incomplete, just imagine how this might look. It's going to look like rows and rows of racks of dresses that are somehow marked off in separate things, and you know that one of them needs something, and you've got to run down the row till you find, oh, this is where this one needs to go. Okay, I'm going to put it there. No, you can't do that, right? That's never going to scale. So you have to have a system that knows exactly what is needed where and makes it just really easy for you to say, okay, put it there, put it there, put it there. The nice thing about this is that it is scalable to the size of our warehouse, which is unfortunately, we're busting at the seams right now, so we can't have as many of these as we would like to have running at this time. But this was really, really important in scaling the physical operation of actually collecting and picking orders. A more efficient way to fulfill shipping of groups. So finally, we have built everything else. Might as well go ahead and build our own shipping system while we're at it. And so we did. And this is a system called Shipmonk. It prints labels, fairly straightforward, right? The nice thing about this is that we need to be able to control not only when things go out, but actually how fast they came back. So in the short run, right, early days, we just said, well, okay, we're shipping them back. We were actually shipping them back USPS. We moved to UPS. We were afraid that our customers were going to revolt, and they just didn't care at all, so that was a lesson learned. So we moved to UPS, which was great, because now we have accurate track scans on when things are coming back, and we can do different shipping return methods with it fairly easily. What is important here is if you look at this graph, which is from a prior year, look at that peak, right? Now, there's the peak where if we didn't turn on next day air, returns, this peak would happen on a Wednesday, and we may or may not be able to satisfy that. Turning on accelerated return shipping for a percentage of our orders smooths that peak out. So now Tuesday and Wednesday are busy, but Wednesday is no longer a terrible, terrible peak for the business. That is the goal of having our own shipping system, so that we can do smarter and smarter and smarter things about return shipping based on what we know about future utilization and future demand for our products, right? And again, shipping is really expensive. So you want to be able to be smart about it, because number one, you don't want to disappoint your customers, but also number two, you don't want to just throw money down the drain or down the UPS, black hole. So this is what we have built up until this point, right? And it has been a pretty, massive effort on the part of our team to get all of this together. We've built, sort of a proto-brain. And this is a slide that I didn't make, but I think it's kind of, funny. The complete just-in-time reverse logistics system, ResCal, Alligator, Baywatch, Chipmunk, Panda. Now, the interesting thing here is really that the typical turnaround window for items coming back to our warehouse is 8 hours, right? 8 hours between when it comes in, gets cleaned, and gets shipped back out. That is quite impressive. And it's just the beginning. Because now that we've done that, we have new problems to solve, such as, how do you do this when you have multiple warehouses? Right now we have only one warehouse, which is fine, that's easy. But if you have 2 warehouses, let's say one in New York and one in California, how do you allocate inventory between those 2 warehouses so you aren't shipping multiple packages to a person? Because again, shipping is really expensive. And you're managing how much inventory you're shipping between these places. This is where you start to get, this is where I wish I could grab someone from the early days of Netflix and really interrogate them, because this was one of the major problems that they had to solve for scaling Netflix. So we have to solve that plus, all of the dry cleaning and those elements of this challenge. The other part of the future here is the following. We have managed to create warehouse processes that work, that scale pretty well for our business. But those systems, for the most part, are constrained to be warehouse systems. It's our warehouse technology, right? With the exception of our reservation system, which does power our website. This is all warehouse, warehouse, warehouse. It has different SLAs, it has different, look, the warehouse doesn't run 24/7, so you can take this stuff down for maintenance, et cetera. But really, the same things that help you determine when you should return items, how fast you should return them, that's a utilization prediction, which is the same thing you want to use on your website to determine how much you should charge for something, right? If something has high demand, high predicted demand, high utilization, you probably want to charge a little bit more for it, right? We're a business, after all. Starting to be smarter and smarter and smarter about understanding our physical inventory and the costs of satisfying that physical inventory, that needs to bleed in to our website. It needs to bleed into the logic of our website. This brain that we've built for the warehouse now needs to actually power the products that our customers are seeing on our website, the pricing of those products, the actual sort of ways that we encourage people, things that we show people, right? If we know that you're interested in a long black dress for a particular date, we have a lot of different things that we could show you. Probably want to prefer to show you things that are going to be easier for us to fulfill than the stuff that's going to cost us a ton of money to ship because it's going to have to turn around in that same day. We want to be able to use this brain to not only improve our warehouse flows, but also to change our customers' behavior a little bit and smooth out those peaks even more. So in conclusion, what have we learned? Well, we went from turning our inventory twice a month every single week to basically turning a lot of it every single weekend with a 0-day turnaround time. So everything comes in and goes out. Having a warehouse is actually pretty crazy and pretty fun. It's a really, it's a very different challenge, right? I am a distributed systems engineer by training. I never expected to be in the business of building logistics software, and it's definitely been very interesting to think about these different problems that are very much not just about machines communicating with each other, but fallible humans that you want to really help make their lives easier and better and their job better. This is like a picture of that picture was actually from 2 years ago. I'm not a good photographer, but it is hard to show the scale of our warehouse because it is just so big and so crazy and so packed and overwhelming, frankly. It's very exceptionally overwhelming during hurricanes, such as Hurricane Sandy, which is the water line rising up to the warehouse during Hurricane Sandy. Fortunately, it didn't actually hit, but Rent the Runway had a very fun time. Just like a sort of side story was our offices were below 14th Street, so we lost power for a week, and our warehouse had to siphon diesel out of the delivery van to run the generator at the warehouse. So it was a very exciting time for Rent the Runway. So what have we learned from all of this experience? This software was delivered in very tight time frames, and it is a very complex software. So you can imagine it has some bugs, it has some issues, especially given that every second counts to the business. Believe me, anytime things are slow, there are emails and phone calls from the warehouse saying, WMS is slow, this is slow, that is slow, what's going on, things are not perfect. Sometimes it's the software, sometimes it's the fact that a lot of the things in our warehouse are run on overloaded Wi-Fi carriers. We're a startup, what can we say? The only benchmark that we have for this business of whether we're doing well or not is really, can we actually satisfy the business growth? We don't have anyone to compare ourselves to because no one else is really doing what we're doing. But I think it is a very exciting problem to be solved, and I think we were actually doing quite a good job of it, and it's worth it to make all of these amazing, happy customers have amazing experiences. So that is all I have to say. Thank you very much. Happy to take questions, comments. Yes?
You have one question. You were saying that when the UPS packages come back to the side, doesn't matter.
Yeah.
You're scanning the UPS tracking numbers?
Yes, so we scan the UPS tracking numbers, and we track, of course, all of those tracking numbers, associate them with the order. And then what pops up on the screen is you actually see a screen with all the things we expect to have in that package and their priority. And things that are low priority are special, they're put into a place where we know this needs to be processed, but it's lower priority.
Okay.
Yeah.
So you've got effectively a distributed system with people and
Yeah.
did you find that your background in distributed systems was useful in terms of or vice versa, that you kind of discover things with kind of new business failure modes?
Yes, that is a good question. I think that I actually did not in the early, I think I have not until recently relied enough on my background of understanding failures to apply to this software stack. So I would actually say that theoretically, yes, my background should have made this whole process of building this software easier and better, and there are probably things that I could and should have sort of predicted, and I just didn't, because I think I fell into the trap of viewing this problem a little bit as different than a high availability website problem, right? So it's like we separated out our software into the warehouse stack and the website stack. And we said, well, it's just the warehouse. And that was a huge mistake, I think, that we have since started to correct, but that, I don't know what I was thinking when I sort of like helped lead us down that path. Yeah?
So if I understand it correctly, you went from a sort of scheduled constraint resolution to a real-time.
Yeah.
Okay. Do you find the performance of that to be lackluster compared to the scheduled constraint resolution?
So the question is, we went from a scheduled constraint resolution, scheduled allocation system to a real-time. No, actually it's significantly faster because we made the trade-off of keeping everything in memory. So that's the risk there, right? This is a singleton system that keeps everything in memory and operates on it very, very fast. But of course, if it fails, you have to have sort of a complex failure, handling process. We actually keep most of the important state in Redis and use that in case we fail to rehydrate another system. Yes. So the question is what do we do on the down days, essentially? How do we keep things busy? We've got all this wasted compute power, as it were. Could we be a cloud dry cleaner provider? Actually, this is not the first time someone has brought this idea up to me. And I actually think it's a pretty cool idea. We have not explored it yet. We're still trying to just get everything done that we need to get done. But I think it's a very interesting idea. Who knows, maybe. Are there any other questions?
So,
Yeah.
I've heard some challenges around managing barcodes and around managing all these boxes coming in and not
Oh, that's a good question. So barcodes rather than RFID. We have been talking about RFID for a long time. The challenge with RFID is a few things. Number one, actually sewing in the RFIDs somewhere into the fabric is a little tough. My understanding about RFID is the technology is, maybe it is now, but certainly as we've explored it in the past, the technology is a little touchy. It's a little tricky, right? So you scan a bin that, and sort of get like a bulk sampling, but then you still have to kind of go package by package and find where the stuff is. And I do think that RFID, especially as a technology evolves, is going to be in our future, but I think that, at least certainly the last time we did an evaluation of it, it just like wasn't there. And when you're talking about a warehouse that has like a whole bunch of metal everywhere, it kind of interferes with the signals and it just becomes a little bit of a, it's like, I think that is part of our future, but we're just not quite there yet. Yeah. Oh, so the dress manufacturers. Yeah. That is, so we definitely work very heavily with the dress manufacturers in a number of other ways. We do some customization of the inventory that we're getting to make it better for rental, for example. That's a very good question. And the answer is, I just don't think we've ever thought about it. Yeah. Explain more specific. Oh, annual. Yes. So yes, annual. So we have. Like I said, we have. Yes. Yes. So the way that we actually do our merchandise planning accounts for annual seasonality. So basically, what we do is we buy a lot of dresses that we call seasonless, meaning we believe they can be worn basically any time. And then we buy a subset of dresses that are specifically spring, summer, or specifically fall, winter. And the goal in the merchandising buying of those dresses, which is a very fashion-driven and data-driven process, is to make sure that even though they will only be popular in season, that they will be so popular in season that they will make up for not being at all popular in their out of season. And so yes, we certainly have, that's part of the reason that you see these real spiky peaks in our biggest, weeks of the year is that, where you have so much of the inventory coming in and going out is that, some of it's just that seasonless stuff that everybody wears, but then the stuff that is in season especially is really, really heavy. New Year's Eve is probably like the biggest example of this because everyone wants something sparkly, short, tight, and possibly long-sleeved for New Year's Eve. And, so that's just like everything that even like remotely matches that particular set of characteristics will be out of our warehouse on New Year's Eve, pretty much. Yes.
Do you guys have, so you've been building up your inventory, do you call it out at some point, or are you, trying to support a long tail? This is, maybe a vintage fashion.
So the question is, do we cull our inventory at all as we build it up? We will keep inventory as long as it is in condition that we believe is good and as long as it is renting. One thing that I think is interesting is that what we have shown is that fashion is less trend-based than most people believe. So yes, there are absolutely trends in fashion, but there are a lot of things in formal wear that people are going to wear for years and years and years. That Fifth Avenue showstopper dress that I showed, that sparkly gold thing, very pretty dress, has been popular for us pretty much since the launch of the site. So 5 years, right? So what we do is we essentially we will rent it until people are not renting it anymore or it's not in the condition that we believe. Yes, absolutely. We do a lot of unit economics on every single style. So we know if something is really just not doing it for us, then we will sell it usually on sample sale. Yes. Yeah. Yes. So the technology stack. So right now we use a very basic technology stack. MySQL is our database. We use Redis for some caching. We use a lot of RabbitMQ for messaging. We use mostly, this system is Java, Drop Wizard for the most part, although some of the early stuff is Spring. We're a big Drop Wizard fans at Rent the Runway. And that is about it. We have not really, we actually do use MongoDB in the company for some of our documents type data, but that's more for the website. And we use, like Memcached and things like that. So it's a fairly simple, straightforward technology stack. I do think that we are going to be looking at new data storage solutions probably for some of the activity in this side of the world at some point in the near future, because we do have additional scaling problems that are just going to come out of, do I really want to turn that single-threaded allocation process, in-memory allocation process, into a complex distributed system? I've done that in the past. I don't really look forward to doing that again, so I'm hoping I can find something that will make me not have to do that. But we've tried to, I sort of believe in simplicity for as long as you can possibly keep it up, and that's where we are right now. Yes?
So you mentioned barcode scanners.
Yeah.
Are there other pieces of warehouse automation equipment that you're interfacing with? And if so, how's that going?
Not yet. It's hard because most warehouse automation equipment is really aimed at boxes, and dresses are just very fragile, right? You do not want, we don't even want something like automatically opening packages, because heaven forbid you should rip a $2,000 dress in the process of opening a package. So we have, there are things that there are cool things in the processes in our warehouse that are automated. For example, we have big steam tunnels. So for that small amount of inventory that has not been worn, or new stuff, right, that we want to make sure it's all de-wrinkled and whatnot, we actually have this cool steam tunnel thing that's basically a constantly rotating screw, and they just sort of hang the dresses on it, and the screw just takes it through the tunnel and then sends it off to our quality control bays, which is kind of cool. But there's no technology. That's just sort of cool warehouse hacks. But no, we don't have any automation. I mean, beyond the scanning, which is actually pretty annoying and tough to deal with. We don't have anything like that. Yes.
How many times do people rip a $2,000 dress manually?
How many times do people rip a $2,000 manual? Not often, actually. No, people are very, very well trained in our warehouse, and everybody understands the cost of the goods. And frankly, we try to buy things that are not going to be too easy to rip, or else our customers are likely to rip them as much as our warehouse staff is. Anything else? Yes?
All these different components, were they built by the same team or different teams in your group?
So all of the components, no, they have been built by, they have been built by multiple, they've been built by the same conceptual team, but we have had people sort of come and go, obviously. We are a startup. So not everything was built by all the same people.
There's shared blood between all of them.
There is shared blood between all of them, yes. Shared, for better and for worse, plenty of shared blood and love and tears and all of that. Any other questions? All right, thank you all very much.